Where are we at?
Having trouble figuring out what to do with it. I can get the answer,
So let's see, 27 says, this is 37. The quantity is initially -5 and decreases at a rate of 20 per day. Whatever this is. Right? Alright. So, what is this? Yeah, it's 20 whatevers per day. So it's a slope, right? It's 20 fall for every one day. So I know that this is going to be sloped. And actually, what number should it be in my equation since it decreases, right? So what number should it be?
-20.
-20. And what's this? Initially -5.
That's y.
That's the y-intercept. I like it. So that's B.
So I thought that the initially -5 would be the 0 with the x measurement on y.
I love it. So this is the y-intercept. As a point, it would be 0, -5, and that's why it's B. I like it.
No, I did it different.
All right. So how'd you do it?
Well, I haven't done it yet, but I was going along with the assumption that the x line horizontally would be equal to -5. That way, when it decreases 20 per day, I could just, and I think that's where I went wrong.
Gotcha. Yeah, because they actually give you, they say a quantity y is initially -5. So where should that be on the graph? If y is initially -5,
Up and down.
exactly. Cool. So it should be.
So isn't the x line up and down as well?
No, this is the y.
I'm sorry, the 0 on the y is the x line.
Yes, that's
And
the.
that's what I was putting in -5, so I just kind of threw myself.
Oh, yeah. You can't. Yeah, it's got to be 0, 0. It can't be anything else.
Right.
Yeah. So what would this be if we threw all this together? Slope is -20, so that's m. The y-intercept is -5, 0, -5. So,
We're supposed to write an equation.
and I just got to throw it all together, right? It's almost too good to believe, these problems. They're telling you in a different way. They're telling you the slope and the y-intercept. But if somebody tells me the slope and the y-intercept, that kicks ass. I know what m is. I know what b is. Just got to throw them in. So the slope was -20. And the y-intercept, the b was -5. Just got to throw them in. All right, I like it. Yes, sir.
Can we do number 1, quiz 5?
Number 1 where?
For quiz 5?
Let's see here. So, all right. Has everybody got what they want from here? In general, so let's just do it because there are 4 different versions of that problem. In general, how do I solve something graphically? So I say, let me give you one that's a little. Let's see, what do you got, Jeff? Yeah. Oh, that's gonna be gross. Wait a minute. It's always weird trying to make one. Let's see. All right. No, it's still gonna be bad. That'll be fun. Okay. Sorry. I gotta make something that actually looks nice when you graph it. Let's see. Okay. So how would I solve this graphically? What would I do first? Yeah.
Add 2x to both sides.
Yeah, for number 2, so in general, what I do first is I try to solve for y. And I solve for y so I know what slope is and the y-intercept, yeah. So if I add 2x to number 2, I'll get 2x minus 6. And number 1, I just got to solve for y, so I'm going to do what? Subtract x, and then divide by 3. So you get there eventually. Stop there for a second. So we all should be able to solve for y. That's why I'm doing that kind of quickly, right? Subtract x, divide by 3. 3 divided by 3 is 1, so that's how I get there. You guys kind of with me? You should all be able to solve for y. It's not the big deal. The big deal here is I still have people that aren't sure how to graph something, and that's huge. If you can't graph, you can't solve graphically, right? So how do I graph this equation? What do I know about it?
Y-intercept minus 6.
So negative 6, okay. And then I go...
Slope, go up 2 and run 1.
Yeah, up 2. This is slope of 2 over 1, so up 2 over 1. Up 2 over 1.
Up 2 over 1. Up 2 over 1.
Okay, that should be enough.
2, 3 points enough, right?
I don't know, we'll see. And then how do I graph this line? Start at 1.
Then go down 1, run 3.
Bam! So I know I'm done there. What's the answer? Yeah, the answer is 3-0. Kick ass. So some of you guys learned the hard way that the most important thing there is you should go into this quiz, this last quiz you took, we should have went into it knowing how to graph the line. So the most points were, if you didn't write that down, you lost a lot of points. Because that's the whole point of it. It's giving me what the answer is. Right? So the answer is where they meet. How's that?
Point. The answer.
Yeah, the answer is the point where those 2 lines meet. Kick ass. Yeah.
Okay, on the section is the substitution. I got some like funky answers. I just want to make sure I'm doing it right.
Which ones?
Let me find it. You could ask someone else something.
Yeah. So on the first quiz when we graph lines, if you did like this, it's no good. Because then that means that it starts there and ends there. That's not true. It goes forever in both directions. So that arrow is a key part of that. And if you don't agree, it's too damn bad. Take some teacher that agrees with you. If they agree with you, they're not a math teacher. I don't know who they are. Because that's a huge part of this. It tells you that it's going forever in both directions. If you don't put it there, then it's wrong. So I only took like a point off for leaving the arrows off, but I want to make the point. You got to put them on there. Yeah.
I have a question with the homework.
Sure.
I'm
Okay.
4360.
60.
Yes.
Ooh, I like it. All right. So number 60, they tell you an athlete runs at 9 miles an hour. And then at 12 miles an hour, covering 10 miles in 1 hour. Okay, so they give you a picture. So the athlete runs a certain distance for 9 miles an hour, at 9 miles an hour, and then another distance at 12 miles an hour. And overall, the total distance they ran
10 miles.
was 10 miles in 1 hour. I think.
1 hour.
Yeah. Okay. How long does the athlete run at each speed? So, what is my unknowns? What are my unknowns?
The first distance and second distance?
No.
The speed?
No. I know how fast. I mean, look at the question.
How many each mile per hour?
How long? Yeah, so the time. So my unknowns are, what are you going to call them? The times. So how long did they run at 9 mile an hour?
X, maybe.
Sure. And how long did they run at 12 mile an hour?
More.
That's crazy. All right. Let me stop right there. I mean, as always, the most important part of a word problem is identifying your unknowns. Because if you do that wrong, you ain't got a chance. Right? So look at the question. The question pretty much tells you your unknowns. That's why it's a question. Right? So I know how fast this person was running. I know how far they went. I just don't know how long they were running at those speeds. Let me let that sink in. Okay. Considering that these are times, what's one simple equation I can write immediately?
9x.
No. Yeah, the time here plus the time there had to equal 1 hour. Be careful. So remember, this is really key. Math has to make sense. So I can't add 2 times and get miles as an answer. That doesn't make any sense. Right? Like I can't add people to people and get money. Hopefully you don't look at that way. Money, money, money. No, no, no. So time plus time equals total time. So if they ran for 9 mile an hour for X hours and they ran at 12 mile an hour for Y hours, how far did they run when they were running 9 miles an hour? How far did they run? 9x. If I knew how long they were running, I would multiply those together, wouldn't I? If they ran for 2 hours at 9 mile an hour, how far did they go? 18. 9 times 2. So how long were they running? I don't know. But the beautiful thing about math is, math doesn't care if you know or not. You do the same thing. Whatever the time is, I multiply it by the rate. In fact, we know distance equals rate times time, right? So rate times time. So the second equation is all about distance. This distance plus
12y.
This distance has to equal
10 miles.
the total distance. Miles plus miles equals miles, so that equation makes physical sense. So the background there was good old dirt, right? Rate times time equals distance. So this distance plus that distance, and that was the picture. That's why the picture is so helpful. However far this is plus however far that is has to equal 10 miles. And now what method, it's up to you, whatever method you want to use. What method you want to use? Alright. Do it. If you haven't done this problem yet, do it. If you haven't done this problem yet, you can knock out some of your homework right now. Nope, that would be difficult. Can't run for negative time. Then you're putting on weight, that sucks. Run for negative time. Oh. No? That joke was just for me. I liked it. So let's see, I don't know what you guys. Oh yeah, you guys said substitution, so solve this one for what?
Y equal minus x.
Okay, so
plus
subtract x. We're so used to solving for y, we might as well keep going. And I didn't have to write it like that. It's not, I can just say 1 minus x. Y is 1 minus x. So I can rewrite the second one, 9x plus 12 times y, which is
1 minus x.
1 minus x. The method is dangerously close to making way too much sense. I don't know if you guys agree with me or not. Y is this. So if I see a y here, I'm going to write that instead. Because that's what y is. And now that you can solve. You won't get a negative because, watch this. So what do I get? 9x plus 12 minus 12x equals 10. 9x minus 12x.
Minus 3.
And then I can subtract 12 from both sides. And what's 10 minus 12?
2.
Negative 2.
Negative 2. Never mind.
So you divide by negative 3. X is
2 over.
2/3. 2/3 what?
First is
Now what were x and y?
the times.
Times. So 2/3 of an 2/3
Hour.
of an hour. Remember what your variables represent. So y must have been what? 1/3 of an hour, because together they make a whole hour. What is 2/3 of an hour?
40 minutes?
Yeah, 1/3 of an hour is 20 minutes, so 2/3 is 40 minutes. 1/3 hour, so together they make a full hour. Of course they do. Okay, maybe. You gotta, something I said earlier, I don't think I've ever said it like that before. Math doesn't care that you don't know what a value is, and it's not that math has the ability to care about shit, but I'm just saying, the process I use doesn't care that I don't know. If I knew he ran for 35 minutes here and 25 minutes there, how much time did he run for? How much total time? If he ran 35 minutes there and 25 minutes there, how much total time?
Plus.
Yeah, 60 minutes. It would be an hour, right? So what did we do when we didn't know what the times were? We still added them together to equal 1 hour because we know that they sum to be 1. We know that the total time was 1. The math process doesn't give a shit that we don't know what those numbers are. Whatever they are, they have to add to be 1. That's why algebra works. People hate word problems. They don't always,
Yes.
word problems. Yeah.
Same section, 63. Or
Oh, I'm sorry. Same one? Oh, yeah, okay. Let me see. First off, I want to point out, I think... Where was it?
275.
Yeah, I know. Let's see if they had an example of interest rate, but somewhere they did. But no, they don't give you one to you. So maybe this was a little evil. You guys know simple interest. So if I had $5,000 and I invested it at 3%, exactly, right? I would make 3% of $5,000 as interest, right? If only I had an extra $5,000 laying around. So let's see. What are my unknowns, though? That's where I should start. What are my unknowns?
How much money?
Is invested at each one. So he had a total of 5,000, and he put some at 3% and some at 5%. Why he didn't put it all at 5%? Don't ask me. It's up to this guy. Maybe it was a little risky. I don't know. Right? We're gonna give him some leeway. It just wasn't like, oh yeah. No. So the total invested was $5,000. What I don't know, my unknowns, are exactly how much at 3% and how much at 5%. So I messed up there. So identify what your unknowns are. I don't know how much you put at 3%. I don't know how much you put at 5%. So how much did he put at 3%? X. I love it. So I love in algebra saying we don't know this. So what is it? I love being able to say that because in algebra you know it's freaking X. And how much do you put at 5%? Why? There's no other letters really make sense there. You can use A and B. You can use whatever you want to. X and Y. 3 and 5. Something about 3 and 5. What's the first easy equation I should be able to write?
X plus Y equals 5,000.
Careful. No. 210 was what? 210 is the 210 was the interest made, right?
So 5,000? No?
Isn't 210 the interest made?
Yeah.
Exactly. But I have how many unknowns?
Oh,
2. So if you want to start with 210, what equals 210? The interest he made from this much money. How much interest did he make?
3.
No, 3%.
So 3% is point.
0.3.
He wishes it was 0.3. That'd be 30%.
Oh.
You see an account given 30%, you put money in it. But it's 3% like normal. So 3% of X plus
0.05.
5% of Y, that would give me the total
210.
interest made, right? So this one's you gotta be careful because all my equations are gonna be about money. So money plus money equals money. But this is interest plus interest equals interest. Total here plus
5,000.
yeah, exactly. Total here plus total there equals total altogether.
I told you first, 5,000.
I know, I want everybody to be with me. So I'm sorry for not giving you props. You're totally right. You're totally right. Let me stop there. So you know that there's a number 5,000 you got to use somewhere. You know there's a number 210 you got to use somewhere. Just make sure when you put it into an equation it actually makes sense. 210 is just the interest that was made. So that's going to involve the interest rates. 5,000 is the actual just money they put in. You can see that. Okay. And now you can do just like we did there. I'm not going to do the rest for you. You can finish it up. Substitution, or you can even do elimination. If you don't like decimals, what could you do? Multiply by 100, because you want to move it twice. You can multiply both sides by 100 if you want to kill the decimals. Totally up to you. I'll let you finish that out.
But with 66, don't you just have to know how big the triangle is to start off with?
Well, no. You have to know what supplementary means. And this day and age of Google and Siri and Cortana, screw that. Turn that thing on. You guys know about Cortana?
No.
Good. Leave it that way. It's the new. Yeah. I just deleted all that shit. Sorry. In the day and age of internet, you can look up supplementary. And what? Anybody happen to know what supplementary angles do? It's crazy. They're like vitamins. So there's complementary angles and there's supplementary angles. Complementary angles add to be 90. And supplementary angles, they're just doing a thing. Supplementary angles add to be, what do you think? Complementary make 90, supplementary make 180. So one equation you can set up is A plus B equals 180, whatever you call the angles. Is that enough to get you going on that problem? Supplementary just means they add up to be 180. A pair of angles.
I have a question.
Yes.
With practice test.
Sure.
Number 5, C.
Can you?
Oh yeah. Huh? What?
Number 66.
Okay. Let's see. So what do you call your angles? Come on, I'll get back to that in a second.
A, B.
A and B, okay. So you got angles A and angle B. Blah, blah, blah. Alright, so they're supplementary, so what must they do?
A, B.
Add to be 180. So what's the equation look like?
A plus B equals 180.
A plus B equals 180. If they would have said complementary, you would have said A plus B equals 90. So I always remember alphabetical order. Complementary C, 90. Supplementary later down, so it's 180. Whatever. No? Screw it. You can come up with your own thing. Complementary 90. Supplementary 180. It's later in the alphabet, so it's bigger. Deal with it.
3 angles. Why is A and B?
3 angles? Where's 3 angles?
The triangle has 3 angles.
But it says the measures of two supplementary angles differ by 74 degrees. Where do they talk about a triangle? In fact, what's the question?
It's not a triangle.
What's the question?
Find the two angles.
Find the two angles. Yeah.
I didn't even read
All right, so that would be really throwing you off if you thought there was a third angle. Some ghost angle in the background controlling things. I knew it. Triangle conspiracy.
It's not a triangle.
The Illuminati triangle. No, okay. So yeah, that should be a lot easier now. How do you write they differ by 74 degrees? How do you write that? Okay, be a lot more specific.
Wait.
A minus B equals, yeah, they differ by 74 degrees. And what method would you use? Please pick the right one.
Elimination.
Elimination. It's set up for elimination, right? The bees want to die. Let them die. It's the right to die thing for variables. If a variable wants to die, let it die. Variable proportional. Alright, so I'm sorry.
So,
Which one?
Number 5, C, the practice test.
Yeah, so let me ask you this. If I had the equation x equals something, what kind of a line is it? Like x equals 2, x equals 7, x equals negative 6, blah, blah, blah.
Vertical.
It's a vertical line. So what kind of intercept will it not have? It won't have a y-intercept. It will have an x-intercept. No y-intercept. So if I have the equation y minus 8 equals 0, how can I rewrite that?
Y equal 8.
Y is always 8. What kind of line will that be?
Horizontal.
Horizontal. So what's it parallel to?
Horizontal?
What's it parallel to? The x-axis. So will it ever have an x-intercept? No. So that's why there's no x-intercept on that one. In fact, how do you find the x-intercept always? How do you always find the x-intercept?
To make,
You make y 0. And if you make y 0, what do you get? If you make y 0, you get 0 equals...
8.
Is that possible?
No.
No. Therefore, what you just did must be impossible. I can't find an x-intercept. Well, how do you find the y-intercept?
X.
Make every x you see 0. So I'm going to make every x I see 0. Done. What's the y-intercept then?
8.
8. So the process always works. It just is a little weird with the special cases. Special cases are always weird if you try to force them to work the way that everything else does. This has a y-intercept but no x-intercept because it's parallel to the x-axis. All right. Maybe. Yes. 6B? 6B. So if I ask you, I know I've said this a million times, but if I ask you to find the equation of the line, what two things do you need? Yeah, point and the slope. So on 6B on the practice test, which one of those things do I just give you? I just give you the point, right? You don't have to do any work for the point. It's just sitting there. So the point is 9, negative 2. Check. How do I find the slope?
From the equation.
Yeah, my line is...
Y plus 4.
No. My line is
Parallel.
perpendicular to that line. So this line I give you... I forgot what it was already. 2. Yeah, why do I solve for y? If I know my line is perpendicular, that means my slope is negative reciprocal of this line's slope. So if only I knew this line's slope, I would automatically know my slope. So the quickest way to figure out the slope of any line is to solve for y. Okay. So this guy's slope is negative 4. So my slope is... So this line, so mine is perpendicular. Remember, two perpendicular lines have negative reciprocal slopes. So this makes sense of the nature. If one's positive and one's got to be negative, that much makes sense at least, right? So they have totally opposite slopes. And now that I know the slope and I know a point, how do I get the equation? Plug it in where?
In the slope and
Do I know B? So I could use this one directly, right? Because I know X and Y, and I know M. Is that cool? You guys look concerned, but that's why that exists. So if I know any point in the slope, I just got to plug them into this. Now I did show you a way to use mx plus b, but I normally don't concentrate too much on that. If you want to do it that way, great. But how would I fill this in? Good. The y piece is -2. 1/4. Good. And I'll leave it up to you to clean that up. Well, you know, it's on the answer key. I'll give it to you. So let me do this. Let me give you the answer key, and then I want to do all of the word problem stuff that I put on there, because I didn't put that on the answer key. I'm just going to do that in here.